And each node has its own sort of level of security, is its own separate entity in the system. And that makes it much, much more secure. Like, sure, you could compromise one node network, but that would absolutely not compromise every other node of the network. And as we move forward, as we get better at being able to create these secure systems, we'll very quickly overtake and offer a better level of security than anything that a centralized entity can provide. You also have a much greater amount of transparency and traceability, and that comes through things like blockchain technology, etc., whereby with Bitcoin, for example, every single transaction that has ever taken place is viewable at any time by anyone for free. And that's kind of crazy, right? I mean, sure, it costs for Ethereum gas, Bitcoin sort of a few bits or whatever to make a transaction, but actually reading the network itself in terms of auditability is incredibly cheap. And that's something which is often sort of glazed over. But I think it's a very, very awesome facet of the technology. Another thing as well is with decentralized networks, you get synergy between nodes as opposed to these sort of data silos or gardens, whereby the nodes that you're connected to generally benefit from you being on the network. And that can happen at various different levels, sort of all the way up to quite sort of meta level. So imagine if you're using BitTorrent. And BitTorrent has, you've got X amount of seeds and X amount of peers. The more seeds and peers you have, the quicker the file is downloaded. With Ethereum, it works slightly differently. Obviously, the more nodes you're connected to, the better view of the blockchain you have. But at a high level, there's a lot of synergy between applications, decentralized applications. But I'll talk a little bit about that later on in the presentation. So yes, enter the blockchain. A distributed network implemented as a global, immutable, shared ledger. And what that essentially means is it's viewable all around the world, it's immutable. Once it's been written to, it can't be changed. And it's shared, and anyone can access it. Access control is through digital signatures. It's open to all, so you don't need an email address. You don't need to be plugged into any other sort of systems other than having a connection to the internet. You can run Bitcoin, for example, on a Raspberry Pi or Ethereum on a Raspberry Pi. You don't need to have all the extra sort of things that we're used to today in terms of interacting with online services. So a well-known example of blockchain is, well, Bitcoin. It's digital, it's uncontrollable, and it's a currency. And it works pretty well at doing those things. It was invented by Satoshi Nakamoto. I guess he was kind of figuring it out in 2006, 2007, 2008, and then released in 2009. You can see Satoshi Nakamoto has disappeared off the face of the earth. Although I think there's a certain Australian gentleman called Craig Wright who might be changing our view on that soon, so we'll see how that goes. But the problem with Bitcoin is that it's really, really difficult, impossible almost, to implement database applications that go beyond simple monetary transfer of value addition.